hey guys, today we're going to be looking at interval and set notation. So we use these types of notation a lot in algebra because we want to write our domain and range. So this is really useful to know, and it's just to help you out so that you'll be able to recognize kind of what we're talking about, or be able to recognize what you're seeing on the screen or there in your book when you're trying to work problems. So let's dive right into this. The first thing we're going to look at is what's called a bounded interval. So a bounded interval is just a set of numbers that are bounded on both sides by some limiting number. So for example, let's say we want to look at all the numbers between 3 and 5. So one way we could write this is as an inequality. So you can see some different examples here. So we could write, let's say we want to start at 3 and we want to go all the way to 5. So we're saying our set X is going to be all the numbers between 3 and 5. Now if you look at this, you might be seeing as you look down the page that there's different ways we could write this inequality. So for example, we could use the less than or equal to right here, or we could use the less than. So what's the difference there? Well, the difference is whether or not we want to include that number b. So over here, we're including the number 5 because we have a line under it. But if we didn't want to include that number 5, then we would need to rewrite it as we could just take off that line. So it would be x less than 5. And we're showing that it's all the numbers up to 5, but it's not actually including that number 5. All right, so just remember that if the line is under it, if it's less than or equal to, that means that it includes that number. So it includes the 3, but our example does not include the 5 because the line is missing underneath our inequality symbol. All right. Another way we could write this is in interval notation. With interval notation, we use brackets and parentheses. So if we wanted to rewrite this from an inequality into interval notation, we could use a bracket. Well, let me pick the right pen. Okay, so we could use a bracket, put our first number, comma, put our second number. Those are the bounding numbers, all right? And then a parenthesis. So a parenthesis means that we're not including that number, and a bracket means that we are including that number in the set. So it's all the numbers between 3 and 5, and we're including 3, but we're not including 5. We could also draw this as a graph on a number line. So we could, here, let me scroll down a little bit so you can see. We could draw this as a graph. So here's our number line. Well, let's try that again. Okay, and we're going to put 3 in here and 5. We'll go ahead and put 4 in there as well. All right, and then we want to graph all the numbers between 3 and 5, but not including 5. So we could show it kind of like this. If we do a solid dot, that means that we're including 3, and then we're going to just kind of sketch in all these numbers all the way up to 5, but we're not including 5, so we'll put a circle. So again, that's all the numbers between 3 and 5, including 3, but it's not including 5. Okay, now I want to go back up for just 1 second because I want to make sure that we understand the vocabulary here. An endpoint, notice right here, an endpoint is just the bounding numbers. So for example, on our right side over here, 3 and 5 are our endpoints. And we can see that with the graph, very clearly they're an endpoint. That's where our set ends. So you can see it ends at 3 and it ends at 5. Those are our endpoints. And then we already talked about a bounded interval. Bounded interval just means it's an interval of numbers that is bounded on both sides. Bounded in this case, in our example, by 3 and 5. And down here, when we're looking at some of these little general examples, A and B are just representing numbers. So it could be any number depending on the problem that you work. All right, let's go ahead and scroll down and look at an unbounded interval. An unbounded interval means that it's bounded on one side. Well, it doesn't actually have to be bounded on one side. but it means that it can go out forever in one direction, at least one direction. So, for example, if we have all the numbers greater than or equal to a, that means we're going to start at a, and then we're going to go out forever. So let's pick a number for a. Let's say that number is 5. So we could say x is greater than or equal to 5. So that means that we're going to have a set that includes 5, and then everything that's bigger than 5. So we could write that as an interval notation. So we would say it includes 5, and it goes all the way out to infinity because it's not bounded. It goes all the way out to infinity. Now, do we use a bracket or a parenthesis to represent or to put next to the infinity? Remember this, it's always a parenthesis. We can't actually include infinity because infinity itself is not actually like a proper number. So we don't actually ever include infinity in our set, so always put a parenthesis next to infinity. Okay, and we can see that also with our graph here. We start at a and we go out to the right to infinity, so it's unbounded. There's no endpoint on the right side. Okay, this one's actually pretty interesting down here. Check that out. It's unbounded on both sides. It starts at negative infinity and it goes out to positive infinity. So this is actually a specific set. This is called all real numbers. So it's every number. It's all real numbers. So that's a special set right there. It includes everything from negative infinity all the way out to positive infinity. All right, we want to look at one more special type of notation today. It's called set builder notation. And so let's take a look at that very quickly here. This is kind of the general look. Oops. Let's try this again. This is kind of the general look of set builder notation. And so we see that it's surrounded by braces. So let's make an example. Let's say that we want all of the real numbers, and I'm terrible drawing these braces. X is just going to identify our set. It could be any letter. So let's use X. And so that identifies our set, and then let's say X is all of the real numbers greater than or equal to 5. So we could write greater than equal to 5, so it starts at 5, and it goes out to infinity. Again, this is just another way of writing the same thing we were writing up above. A few examples that they have down here, you can see that this specific set is all the numbers less than or equal to a. It includes a, the number a. And then it's also, it could also be any of the numbers greater than b, but not including b. All right, so all the numbers less than a and equal to a, and all the numbers greater than b, but not including b. And then this one's actually kind of interesting as well. Check this one out. That is all numbers except a. So it's everything greater than a and it's everything less than a, but it doesn't actually include a. And you can see how we would write that in set builder notation. It's all the numbers x, the set x, but x is not equal to a, so it doesn't include a. All right, so that's the end of this lesson. In the next video, we're going to do kind of a part 2, and I'm going to show you a few examples of how to write things in different notations or how to convert from one notation to the other notation. So check that out, and that should help you as well. All right, guys, y'all have an awesome day.